thank you everyone for coming. And it's great to be here. I will give a very brief introduction of the Human Cell Atlas Consortium. And I just want to acknowledge Aviv and Sarah, who have put in all the slides that I'm going to show. So I won't do any justice of what they have done and achieved, but they gave me the opportunity and honor to kind of give you some of the latest highlights that are ongoing and some of the visions that have been laid out at a recent Barcelona meeting. So I just thought that I could just use this opportunity to give you a little bit of background, the mission and the direction of the Human Cell Atlas. And hopefully that will give you some insights to what the next 2 days is going to be like. So really, Aviv, Sarah, and Orit, Dana, Per, and Ania have really contributed to the production of this presentation. And how many of you have ever been to the Human Cell Atlas General Meeting? So they, very much. Okay. So we had one in Tokyo earlier this year. We also had one in Barcelona. So if you've been there, probably this is a little bit redundant. Forgive me, but I think this will be important to share with everyone, at least so that we are on the same page. So most of you may have seen this. So ultimately, can we achieve some sort of a table or chart that will define an individual cell type that are in the human body? And you'll see later that this definition of cell type is extremely difficult and very complex, and it's multifaceted. And we have to really understand what is a cell type or cell state in respect to various conditions and tissues. And this will all put into the context when we start to build this type of table and be able to use ultimately as a common language that we can all rely on. And the analogy that a lot of people like to use, and I comply with, is that the Human Genome Project have led to a human reference genome. And I think most of you in this room probably rely on some sort of reference genome that you use to map your RNA-seq or your ChIP-seq data. In the same token, can we create a reference human cell type or human cell atlas where every scientist and even clinicians can use to compare their cell types to and to understand how much they're deviating from the normal standard healthy states, for instance. So really defining this international code or international understanding of reference cell type is critical, and hopefully that will become a useful resource for the communities around the world. So Human Cell Atlas have been around now for almost 3 years. In 2016 in London, had the first meeting. And ever since then, there's been a lot of evolution of the discussions, the aims, and some of the white papers that have been started to be written in London have even now been transformed slightly because of many new technologies that are being introduced, but also the vast amount of interest from the many scientists around the world. There have been people volunteering and actively engaging to provide new insights, new technologies, new samples, new computational tools, and all of that have contributed to this rapid evolution of how to define a human cell atlas. So maybe in the next few slides or so, Aviv and Sarah and many members of the organization committee have kind of thought of how we can define a cell type and the program of a cell type in a more effective way. So before that, again, like I said, the membership of the Human Cell Atlas is rapidly growing. Now there are about almost 1,600 members who are signed up to this consortium. And this is a number from the Spain meeting, because we were just there in Barcelona. But it's in Asia, I believe it's over about 500 in range. And mainly there are people from active PIs who are involved in this. And there are almost 14 organs or different systems that are being represented. And for instance, in nervous system, there are 306 members participating in the same system. And I think we'll get into this topic later as to why that is so important to have multiple members working on the same system to define the reference genome, a reference cell type. So here is just a snapshot of the data that have been collected thus far. For instance, in liver, there's been already 43 different individuals from 50 samples of this, and 100,000 cells have been already collected. What's quite surprising here is the developmental tissues have already 4.2 million single cells already deposited into DCP, one of the largest of all the tissues that have been profiled. I think I can probably safe to say that the reason why that has been is because of strong funding back from the national funders who have really made this developmental tissue as a major focus of the Human Cell Atlas. And I think that ultimately have led to this proliferation of cell types that are available in the Human Cell Atlas database. So this number is rapidly growing, and I think the discussion as to how well represented they are is another discussion point we can have in this next 2 days. And I believe Shin and Unyang will also touch upon the missions for Human Cell Atlas Asia and how we can also promote more equitable data set from the region. So to make this feasible, there needs to be a huge coordination across multiple working groups and organization committees and various members. So there are a lot of discussions on which systems to focus on at which level, organ, tissue, region, cells, nuclei, where the tissue is coming from, ethnicity and gender, age is a very important issue to talk about, and how much can we cover this. What are some of the methods that we need to develop or consider in order to achieve this? And again, what are some of the organization efforts regarding computational working groups or technology standardization working groups, or now ethics working groups and equity working groups? So there are a growing number of working groups and task forces that will really help to coordinate a lot of these ideas so that in the end we'll have a data that is widely usable and accessible. So this is a slide that has been first introduced in Barcelona already last month. And I think this really provides a general understanding of where the Human Cell Atlas 1.0 is going to go. So we say it's 1.0 because Human Cell Atlas will always going to be a evolving process. There will always be a draft, and I think there will be a continual growth of what the Human Cell Atlas will be. But at least we want to have some direction or some vision as to what the 1.0 Atlas will look like and what that Atlas will consist of. So hopefully, once we generate large number of samples and cell types, can we then identify and clearly define what the cell types are and what are the cell states within those cell types? And can we also understand their transition states? And what are some of the programs or gene networks that are consistent and critical for that cell type, cell states to be defined as? And there are now critical understanding and importance to figure out where these cells do come from. In context of a microenvironment or the niche or in the tissue, where are the positions, and understanding this and recording that in conjunction with the molecular profile of single cell would also be critical to understand the Human Cell Atlas. So you could imagine thus far when we dissociate single cells and do RNA sequencing, that's really the population census exercise. We're trying to figure out what are the population of this particular cell type, but really to build the atlas, right? If you want to have a map, the spatial component is critical. And now I think, 3 years ago, there hasn't been much talk about this, but I think it's becoming more of a realistic goal to really consider spatial component into the consortium and be able to integrate a lot of these information at the same time. So can we at some point have this, when we have a single cell profiling, can we define that by a type or state position in the program for individual cell? And this multifaceted information for individual cell across the human body will really provide a rich understanding of cell type and required for development of Human Cell Atlas 1.0. So hopefully that will give you some of the ideas of what kind of technologies will be needed, what kind of coordination of sampling will be needed. And hopefully that will start some discussions and provide, initiate new collaborations as well. This is important to say, of course, what I just said is technology and sampling, but I think computational aspect will become more of a relevance. Hopefully there'll be new innovative tools and algorithms that can also help to understand and define cell states or infer new programs for individual cells. I think that one of the questions that was main focus in Barcelona meeting is, what kind of questions do you have with the Human Cell Atlas? So if you're a biologist in the room, or if you're a clinician in the room, and you imagine you have this complete Human Cell Atlas at your disposal, what would you going to do with it? What are the biological questions and the queries that you're going to ask? And I think we need to collect more of these informations and questions, and that will really also help us to define what kind of data sets we need to generate. And hopefully there will be enough information that most questions could be addressed, but I think every question is valuable, and not every question have been heard. So hopefully through this meeting that we can also start asking really interesting and relevant questions that will also help the Human Cell Atlas become more valuable for the community. So I think in order to achieve this, there's still a lot of work to be done. I think number of individuals, in terms of the spectrum of genetic diversity, we really have to consider what is the right number of individuals. I don't think there's a right answer at this point, but also what are some of the anatomical samplings and regions that we need to consider. How do we record this in a coordinated fashion so that when we perform this experiment in Japan, it is equivalent to the same region in Singapore and in Korea and so on. So I think there's something we have to consider. So a lot of these hinges upon the effort of equity working groups. So it's led by Alex, Shelak, Musa, who's here, and Partha. And this really is an effort, one of the effort that will propel HCA-Asia to also bring about greater representation of Asian population in the Human Cell Atlas. And hopefully there'll be a lot of discussions about this. I think we do have to keep ethics in mind, and hopefully that will allow us to make sure that the data that we generate are as open as possible, at the same time respecting the privacy of the people. So striking that right balance is a big challenge, but there is a strong effort within the Human Cell Atlas to provide kits and documentations that will help and facilitate many researchers to go ahead and supporting the ethical documentation. So hopefully we do have to measure some level of success, and how do we measure that? And hopefully that can be measured through utility of our database, and that could be based on number of entities we recover. So again, how many cell types, programs, and modules, but also what are some of the successful queries. So I mentioned what are the biological questions and queries that we have, and can we actually address those questions? And such type of abilities will help us to define what a successful database really is. Again, deviations. So these are really important relevance for clinical community. And if you do have perturbed cell types or disease cell types, can it accurately provide good prognostics or diagnostics for individual patients? And can we further continue to gather information that will help us to complete the Human Cell Atlas? Because again, we are still in this drafting phase, but what are some of the information that we need to complete it? And that will still be an ongoing effort, and hopefully a lot of the discussions that we have will help to go towards that direction. So this is actually a slide that I generated, and it is the data that was generated in Japan, except the bottom left. But I just want to show you that even taking a single cell profile of a human skin, the cellular composition is highly variable. So again, in order to create a Human Cell Atlas reference map, how do we achieve this across multiple laboratories? So we do need a good discussion on making SOPs and standardization, and how do we define the gold standard of the skin? For instance, what is an expected number of cell types and cell states and programs? So this is just an example of 4 methods, but imagine if you have hundreds or thousands across different laboratories, would that provide a much rich and informative reference data set? So to achieve this, hopefully many of us are relying on sharing our protocols, and I think this is very first step to allow sharing the protocols of how we achieve these dissociations and profiling, and hopefully that will help to bring the communities together. And this is just my last slide. Hopefully this will start the discussion of how do we leverage the power of N in terms of sampling size. How do we tap into regional diversity, genetics, gender, and environment? Hopefully, one thing that we don't really talk about in the Human Cell Atlas General Meeting is disease, and I understand it is not the main focus of the general meetings, but here in Asia, I think there are some common and rare disease that could be relevant, and hopefully that could also be a common discussion that will bring people together. So hopefully that will lead to collaboration, that will lead to higher standardization and high value in data set. So hopefully there'll be also more discussions on computational solutions. And I think it's really important to engage not just the regional here, what we're doing, but once we go back home after this meeting, can we reach out to regional, local communities and scientists and bring people together and get the funders excited about supporting these efforts. So in Japan, we also have now created a network of clinicians and scientists where we're collecting samples and providing the single cell platform. And that data will then eventually be provided to the Human Cell Atlas. And that could really be achieved within individual countries. So hopefully we can take home a lot of the knowledge from this meeting and talk to your local communities to get them excited and contribute their data for the Human Cell Atlas. So with that, that was rather quick, but I'll stop now and move on to the next speaker. So thank you.